right, last section, real world triangle problems. All right, so it's just one example, that's it. It says, as a ship sails into harbor, the navigator sights a buoy at an angle of 15 degrees to the path of the ship. The ship sails 1,000 meters further and finds that the buoy is now making an angle of 25 degrees. So let's draw this picture. Let's say here's the ship, because I'm a master drawer. And let's say here's the buoy. I know. All right, so it's sailing into the harbor, and at first it sights the buoy at an angle of 15 degrees to the path of the ship. So if we'll draw, I got my ruler today. If I draw, here's the path of the ship, right? And if it's 15 degrees to the buoy, this is not best. That means 15 degrees is right there to the buoy. All right, then it says that it travels another 1,000 meters. So let's say 1,000 meters is, let's say, to about here. We'll say this distance here, they go 1,000 meters. And then the buoy now makes an angle of 25 degrees. Now the ship is over here, and we're just going to draw that. We got 25 degrees there. All right, so what do we want to know? Okay, so that's all the information they gave us so far. The ship started off with a 15-degree angle after it traveled 1,000 meters. Then it now is making a 25-degree angle with the ship. So the first thing they want to know is, how far is the ship from the buoy at the second sighting? So we want to know what this distance is here. Yeah, because now the ship would be right here and this distance would be there. So I'm going to redraw this triangle just to make it so that I'm not making a super huge mess. And what do I know? I know this is 1,000. I know this is 15 degrees. I want to know this distance here, right? Because here's this x for this first part. Yeah. Okay. So do I have enough information? Well, I actually do, because they told me 25 degrees is here, and the straight line makes 180 degrees. So that means that this distance, or this angle, is 180 minus 25. And so that's 155 there. That also means that since I know two angles, I know the third. These three angles add up to 180. And so that makes this angle 10 degrees. All right, so I can use law of sines, right? I need x, I need this side length, so I'm going to put that on top because that's what's unknown, over sine of 15 degrees, and that's equal to, I know the side with 10 degrees, so 1,000 over sine of 10 degrees. And so your x will be, you would multiply both sides by sine of 15 degrees. So 1,000 times sine of 15 degrees over sine of 10 degrees. And we'll put that in. 1,000 sine of 15 and the parenthesis divided by sine of 10. And I get 1490.4 blah, blah, blah. I'm going to end up using this later, so I'm going to store it right now. I'm going to store it under A. All right. But my answer to how far is the ship from the buoy, it's about 1490 point, it was like 479, blah, blah, blah. I'm going to store that long decimal as A, but my answer is going to be 1490 point, let's go to two decimal places, 0.48, and then it's meters. So that's the answer to part A. But I have stored this value in case I end up needing to use it, which we will. Okay. Next question. What is the closest the ship will come to the buoy? Well, the smallest distance between two things is the perpendicular distance. So when they ask for the closest, this perpendicular line will be the closest. Like if the ship kept on going and was perpendicular to it, that's when it'll be the closest that it'll come. And so the closest is always the perpendicular distance. So obviously the ship would need to keep on moving to get to the closest, but if we want to know what the closest is, then that's what we're going to use. So now I'm going to redraw the triangle that I'm going to use this time. I'm going to use this right triangle that I know is 25 degrees here. This is my new X value for the closest part. That's what I want. Different X from here. If I erase that one, I don't want you to confuse it. This is a new X. I'm trying to find the closest distance. And then this length here is what we just found here. This guy, this X, I guess I could have done different letters, huh? Oh well, too late now. But this is my stored A value. That hypotenuse here is the distance we just found there. Well, that's nice. That's a right triangle trig. I have, for this angle, I have the opposite side and the hypotenuse side, and that would be sine. So sine of 25 degrees is opposite over hypotenuse. And so to solve for x, I'm just going to multiply both sides by that stored A value. So x will be that stored A value times sine of 25 degrees. Let's put that in there. I'll do A times sine of 25. And that gives me 629.903 times, oh, it's about 629.9038, blah, blah, blah. I'm going to say that I'm going to store this guy, by the way, in case I need it, which I probably will. Let's store it. Stow, and I'm going to store it under B. All right. It's stored. All right. So my answer for part B would be 629.90 meters if I'm rounding to the 10th spot. Okay. Now it says, how far must the ship go from the second sighting point to this closest point of the approach? So what they're wanting now is this distance here. How much further do they need to go to be perpendicular to that buoy? So now, same right triangle, right? And now what I want is this x. I know this is 25 degrees. I know this is my stored A value. And now I know this is my stored B value. Okay. So what do I want? I want x. You could either use B or A. Doesn't really matter. If you use B, this would be opposite over adjacent. If you use A, this would be adjacent and hypotenuse. So you're either using cosine or you're using tangent. Doesn't matter which. I'll use tangent. Tangent of 25 degrees is that stored B value over x, which is what I'm trying to find. This time to solve for x, you would need to multiply both sides by x and then divide by tangent. Multiply both sides by x, and then divide by tangent of 25. All right, so what we got now? We've got the stored B value, B, which was the 629 point blah, 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 divided by tangent of 25. And this time I've got 1350.833, blah, blah, blah. I'm going to store this one in case I need to use it. Store, especially if you've got multiple parts, A, B, C, D, like you should be storing these values so that way you're not rounding to the end. So I stored it, but what's my answer going to be? 1350.83 meters. Rounding to the nearest tenth. Okay, last part. when the ship has gone 6,000 meters beyond the second sighting point, what will be the angle from the bow of the ship to the line of sight with the buoy? All right, so we've got, try to make it neat, so whatever, it doesn't matter. Okay, so I've got, what do I know? I know from here to here, here's the buoy. Yeah. And I know this was 25 degrees. And there's that guy. Okay. What I know is I want to know, okay, so when the ship has gone 6,000 meters beyond the second sighting of the buoy. So the second sighting of the buoy was 25 degrees here, not the 15, right? Because we're talking about from here, if we go 6,000 more, right? We go out here and go 6,000 meters, right? Then what they're wanting is what's the line of sight now from, now the ship is over here, right? And from the bow, we're going to want that angle there. Like, what is that angle from the bow going from here over to there? Yeah, that makes sense. Okay, so let's draw what we know. So I'm going to be going past this point, and we're going to have some angle there. And the angle from the bow is going to be like that, is what we're going to want. Okay, so let's fill in what we know. This, what I stored here, this distance here, is that stored C value that we found on the last one. Is from 25 to that perpendicular spot, is that guy. I don't know this distance here, but what I do know is that it went 6,000 more. So the whole distance is 6,000 from this starting, or that wasn't the starting point, that was the second sighting point, right? To this edge here is 6,000. So that means that this guy is 6,000 minus that 6,000 minus the stored C value. That's what I know about this distance here. I know I stored this guy right here as B. That distance there I did as B. And I know I have this one here was what I stored as A. All right, so what's going to help me? Well, to get this guy, if I can find the angle on the inside of this triangle, if I can find theta right here, then I can find this angle from the bow is 180 minus theta. Yeah? So can I find that? Well, we can, because I know this side, which is the adjacent side to theta, and I know this side, which is the opposite side to theta, which is opposite and adjacent. We're going to use tangent. So tangent of theta would be the opposite side, so B, divided by the adjacent side, which is 6,000 minus C, the stored C value. All right, so then that means that my theta will be inverse tangent of that guy. All right, so let's put that in. I've got inverse tangent of B divided by, and then the 6,000 minus C, I need parentheses around that. 6,000, if you don't put parentheses around the bottom, then it'll divide by the 6,000 and then subtract the C. So I want parentheses around it, minus my C value. All right, so I get that theta is about 7.7158, blah, 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 which isn't what I want. What I want is this angle here, right? So the angle from the bow is 180 minus that theta, And so I'll just go 180 minus my answer, which gives me, it's allergies, don't worry, 172.28 degrees. And that's the answer there. All right, that is it. I hope you all maybe have a fabulous day. Bye.